Hello. So today we're going to be going over dividing complex numbers. And I forgot the L. Oops. This is why I'm doing math. Okay, so for dividing complex numbers, the first thing I want to introduce you to is what's called the complex conjugate. It's a funny term, but it's incredibly important to remember for what we're going to be doing. So, the complex conjugate is actually very, very simple. So let's say this is our complex number to start with, a plus bi. Simple enough. Now the complex conjugate is a minus bi. So for example, let's go 3 plus 4i. The complex conjugate for this is going to be 3 minus 4i. It's incredibly simple. All you do is you change this plus to an addition. Now, why is this going to be important? Well, of course, I'm going to be getting to that. Now, really quick, I want to go over what really happens when we divide two complex numbers. Well, let's say we're doing, for example, 2 plus 3i. I would give you a list of rules of what to do, but I'm going to just do this with one example, and I'm going to walk through it with you guys step by step. Let's say we're dividing this by 3 plus 4i. That's an awful 3. Okay, now what we're going to be doing is we're going to multiply both the top and the bottom by the complex conjugate. Now, why would we do that? Well, whenever a number is multiplied by the complex conjugate, let me scroll back up real quick. What you're going to do is you're going to be able to get rid of these i's. So here, let's real quick multiply these two together. Now, we do FOIL, just like always, and we do first, so we have 9, and then we do outside, negative 12i, and then we do inside, plus 12i, and then we do the last, which is going to be negative 16 squared, negative 16i squared, like this. Now, this is going to simplify out. We can get rid of those because it's minus 12 and then plus 12, and this is going to end up being plus 16, because remember, we have this I squared here that turns into negative 1. So we have 9 plus 16, this equals 25. Now, because we multiplied this by the complex conjugate, we were able to get rid of all the i's and end up with one solid answer. Now, that is why here we're going to multiply each of these by the complex conjugate, because it's just like working with any set of fractions. If you multiply something at the top, you have to multiply at the bottom by that same number. So as we already showed here, we'll go back through the steps. You go first, just 9, and then, because this will now have parentheses around it since we're multiplying it by something, so we go first, and then we go outside, so minus 12i, and then plus 12i, and once again we get negative 16i squared. Now we also want to multiply the top out. So we go first, we have 6, and we go outside, minus 8i, and then we go inside, so we have plus 9i, and then we go inside, which is going to be negative 12i squared. And then all we do is simplify both of these out. Now, we've already simplified the bottom out because that was the same example we used earlier. This ends up equaling 25. Now, that stays in the denominator, and now the numerator is all we have to simplify out. So we have 6, and then the negative 8i plus 9i equals just I. And then remember, we still have this I squared, so this actually ends up being plus 12. So this all simplified out ends up being 18 plus I. Now, all we end up doing is putting the 25 in the denominator. So 18 plus I over 25 is the exact same as 2 plus 3I over 3 plus 4I. Now this is incredibly simple. The only thing that's hard is remembering that you have to multiply by the complex conjugate. Now just remember that when you multiply by the complex conjugate, why you're doing this is so you can get a normal standard number in the denominator. If you can't divide something like this by a complex number. You have to have at least one normal number. You have to have at least a regular number within the denominator. Now, if there's anything else you need help with, the book does a great job of explaining it, and also Mr. Hemphill is always there for everybody. Until next time.